All right. Good afternoon, everyone, and welcome. I'm Mariane Medeiros. I'm the Senior Project Manager at the Northeast Recycling Council, NERC, and I'm happy to welcome you to part two of our webinar series of the benefits of AI in the waste stream. In today's session, we'll explore how AI is being used to innovate recycling processes, tackle construction waste, and drive sustainability initiatives. Our speakers will provide insights into their solutions for reclaiming valuable materials to align with the circular economy. So before we dive in, here are a few important notes. This webinar is being recorded, and a recording and a copy of the presentations will be made available on the NERC website, nerc.org, and you will receive an email with the link afterward. Please use the chat box to submit your questions, and we will address all the questions during the Q&A session at the end of all presentations. So now let's meet today's incredible speakers who are driving innovation in recycling. So for our first speaker, please meet Apurva Pradhan, Head of Product and Marketing at Everest Labs AI. Apurva is a seasoned product and marketing professional with more than 20 years of experience leading product and marketing teams. At Everest Labs, Apurva has helped craft the company's strategic roadmap, align objectives with recycling value chains, and drive innovation that supports the global circular economy. With his extensive background in commercial and industrial infrastructure, he brings a wealth of expertise to today's discussion. So just to remind you all, once all the speakers have completed their presentations, we'll move into the Q&A portion of the webinar. So please submit your questions while they're talking and we'll go through them by the end. Thank you. And Apurva, it's with you.
Thanks, Marianne. Can you hear me?
Yes, I can hear you well.
Perfect. Thanks, Marianne. Thanks, NERC, for having me on to speak on this topic. I'm going to share my presentation here. Second. Yeah, so I'm going to spend the next 15 or 20 minutes talking about AI for packaging recycling. So packaging is a huge part of household recycling. So if you look at your recycling bin, you'll find that most of the materials in there are packaging waste, things like containers, wrappers, bottles, cans, all of these things that are used for packaging, which are part of our waste stream and part of our recycling stream. Everest Labs is a AI and automation robotics company. We've been in the business for about 6 years now. We have nearly 100 of our systems, AI and robotic systems installed in recycling facilities throughout the country, North America. And what I'm sharing with you is sort of the learnings that we've had as we've worked closer and closer with recycling companies in helping with the packaging and household recycling stream. Just as a way of introduction, I know there's probably people who are very familiar with recycling facilities, material recovery facilities, reclaimers, reprocessors, so on in this call. But there's probably a lot of people who are also fairly new to this sector, learning more about recycling. So I'll keep it at a very high level. If there are questions, my contact information is at the end of this presentation, which you can download and just contact me. But I'll start with sort of a macro picture for recycled content. Recycled content in packaging, the demand for it is going way up, as most of you probably are familiar with. It's driven by regulations, especially regulations that are placing responsibility on producers for recycling more and using more recycled content. A vast majority of CPG, consumer product goods companies, have pledges around making their products more recyclable, but also using more recycled content in their packaging. There's a big benefit from a climate perspective, not just from a pollution standpoint, but in terms of savings, energy savings, greenhouse gas savings. There's a huge positive impact of using recycled feedstock versus mining new materials for making packaging. And all of that awareness is leading consumers to demand more recycled content in their packaging. And there's a lot of studies out there that say that consumers are willing to pay a little bit more if their packaging were more sustainable. So all in all, the demand for recycled content is going up. If I look at sort of the supply side of the picture, it's not the same. It's not as rosy as the demand side of the picture. The supply is fairly unstable, and some pictures here are symptoms of that instability in supply. So the picture on the left-hand side is a typical. This particular picture is PET, which is a type of a plastic, but this is similar for all types of plastics, different metals, things like that as well, where recycled material actually costs more than brand new virgin material. It's about a 20% premium at this point in time, but that fluctuates. Also, the pricing for recycled material fluctuates quite heavily. It's in the last year, it's fluctuated about 30%, but we've seen years where the pricing have fluctuated up to 100%. So these are sort of symptoms of an unstable supply of recycled content. On the right-hand picture is a picture by McKinsey and Company, which state that the demand is going to far outstrip the supply, even with conservative estimates. I think that the predictions are that this demand, if you do nothing about it, the demand will be 3 times higher than supply. So all in all, demand is really strong. Supply is very unstable in the recycled commodities market. And why is that? One of the big reasons why that is because of operational inefficiencies in what I'm calling the recycling value chain. So if you follow this value chain here, let's start with sort of the left side of this picture. Consumers throw away recycled materials into their recycling bins. They typically go to what's called a material recovery facility. These facilities are in charge of separating and sorting recycled materials. That's their main job. And a lot of the material recovery facilities lack visibility into their operations. They have very little information on what's coming in, what's going out, how materials are moving around in their facility. And they also rely a lot on manual sorting. And manual sorting is not very scalable. So one of the big problems they have is keeping their costs low while increasing recovery of materials. From there, it goes to reclaimers, reprocessors. These are companies that are buying bales of cans, containers, paper, bottles, and reprocessing them back into useful materials. So turning them into flakes of plastic or pellets of plastic or rolls of aluminum, which are coming from these recycled material. And here they have a big problem of, they lack high quality feedstock. So they can't get enough recycled material from their supply chain. And one of the big things that happens if they can't do that is, they're unable to rival the economies of scale that virgin material producers have. So their costs are always going to be higher because of a lack of supply, good quality supply. If you follow that chain even further downstream, you talk to packaging manufacturers. These are people who are buying these feedstock and turning them into cans and bottles and brand new cardboard boxes, things like that. Because they lack consistent supply at low cost, they can't commit to these programs, right? So if you're a packaging manufacturer and you have to make a decision, it's a hard decision to make when you have to pay 20-30% more for recycled content. But at the same time, you're not very sure that you'll have guarantee of that supply for the life cycle of that product. So it's a hard decision for them to make, and a lot of time they make the decision not to use recycled material, and that leaves brands short of their commitments for sustainability, and it leaves sort of unhappy consumers at the end of the day. So this whole value chain, really, a lot of problems in this value chain stem from lack of visibility, lack of operational efficiencies, automation, and that is the problem that Everest Labs is out to solve. And so I'll talk a little bit about our AI solution and what it enables. Our product is called Recycle OS. There's sort of 3 major components of that. The first is an AI, and I'll give you a little bit of a demo of this. The AI, what it does is it digitizes, it takes videos of the recycling stream, and it digitizes that information. There's computer vision and AI models running in the background that are identifying these objects, which digitizes those objects. Then that information is then available to the recycling operators through a cloud data platform that give them visibility into their operations. They can track performance, they can optimize their sorting, they can audit their plants. And after that information, they can make decisions to automate the sorting process. And we also provide robotics that are extremely flexible that can install in almost any location and do a very good job of recovering very specific material. And so we have sort of three components of our solution. I'll give you a closer look into the AI portion of our solution. This picture is a picture of our AI model. We call it it's a custom built model for the recycling domain. We call it a large vision model. It's a multimodal AI that can take inputs such as images of objects. It can look at texts and images within objects, for example, logos and writings. It can even take an input like a spectral scan or a line scan from IR cameras or X-ray detectors. And those are all information that it can process as inputs into different channels of inputs. And that data set we balance and provide to our AI network. The AI network is optimized to make very, very rapid inferences around that object, and it creates a set of attributes for that object, and the attributes are listed here. Some of the attributes are listed here. It'll tell you what material type it is. So, for example, you can tell between a PET, an HDPE, or a polypropylene, or aluminum, or tin. All of these different material types. It can gather that information. It can gather information around the packaging type, whether it's a bottle or a container or so on. You can even detect things like brands within that container, that packaging. It can give you the shape and a size and a mass estimate. We obviously calculate motion of that object as it travels through the conveyor. It can calculate things like where's the best place to pick that object. It can also compute for you, if you pick that object, what is the sustainability benefits of picking and reusing that material. So this whole AI network is a closed loop system. We have a testing framework that's continually testing how well the AI is doing, or continually training the model so it's getting better over time. And at this point, I think we're training our AI with about a billion to 2 billion objects. So it's very robust at this point. We've had this model running, or a version of this model running since 2018. So we've had several years of data we've collected and trained this model with. So it's getting very, very good at recognizing these kinds of objects. And from that data, you can do one of two things. You can use that data to optimize the plant and also optimize the packaging life cycle. And with that data, you can also automate the sorting through robots. Here's a little demo of this action of what I've just described to you. So the left-hand picture here, there's a little video here. I'll play that. Oops, sorry. So this is sort of a typical picture of how materials move around in material recovery facilities. There's a conveyor that's running anywhere from 100 to 200 feet per minute with lots of material on top of it. This black box here houses our vision system. So it's a pair of cameras that take video images of the material moving underneath it. It creates a 3D representation of the belt. Pause that. And then what you're seeing now here is what the camera sees. And the AI is then making a determination on all these objects. A few of the things that you'll notice is there's a lot of objects here. And as you know, this AI can detect way better than a human can looking at these objects. There are hundreds of objects in any frame of video. And so this AI is making a determination on hundreds of these objects at any given time. These materials are moving fairly quickly underneath it. So it has to make an inference in very, very quick. We make an inference somewhere around 15 to 30 milliseconds. To give you a sense, that's about 10 times faster than a vision model that's running in your self-driving cars, for example. So it's a very robust AI that's been developed to be optimized for accuracy and speed. And then with that information, then that sort of instructs the robots downstream to pick whatever material that you programmed it to pick. It's a fully turnkey system, which means it's operated remotely. The recycling operator only has to install it and tell us what you want it to do. You can specify how many different types of materials you want to pick, where you want to drop these materials. And we program these and monitor these so that it's running throughout the period of the day that the plant is operational. All right, so what can you do with this data, right? The output of this AI is very remarkable. It serves a wide range of players in this value chain that I talked about earlier. Some of the things we do is we extract insights into the material composition. So what's coming in, what's going out of recycling facilities. Through this data, material recovery facilities can determine their recycling rates, their recovery rates for very specific commodities, and they can do this every hour, every minute, every object, which was not a capability that they had before AI came into the picture. We also provide operational intelligence. So MRFs and reclaimers, they have industrial machinery that are running that can be optimized if you had real-time data of what's coming in and out of those machines. And so that data can help improve the performance of those machines in terms of increasing their recovery and yields in terms of reprocessing that material back into feedstock. For packaging companies downstream, we can help them assess the life cycle of their packaging. So once they make something that's recyclable, we can inform them whether that packaging was indeed recycled or not. If it went into a recycling facility, where it ended up in a recycling facility, and what they could do to improve the recovery of that material using data that they've never had before. And for brands, we can provide information around circularity of their packaging. So brands have commitments in terms of recycling rates, recovery rates, and a lot of those commitments are sort of gone without actually measuring the success of those programs. And we can provide data to actually help brands understand where they are in terms of their circularity commitment. So the AI can provide data that serves a wide range of use cases and a wide range of players in this whole value chain. And data is great, but outcome and impact is even better. So we work with like I said, various players in this value chain. We can save MRFs quite a bit of money in terms of labor savings. These robotics are 2 to 3 times better over a course of a shift of picking versus manually sorting these. So there's a labor saving component. We can recover better. All in all, lower their costs and increase their recovery. And we've proven ROIs less than 6 months in going into material recovery facilities. With reclaimers who are buying these materials and processing them back into feedstock, we help them increase their supply so they can go to suppliers who are providing them with materials and be able to use less clean feedstock, which means they can increase their supply base, but they can also lower the cost of their supply. And we can allow them to run at very high utilization in their plants, which is helps them bring their economies of scale closer to virgin material production. And then we can help on the right-hand side here, brands with their sustainable packaging efforts, help them lower the cost burden of meeting regulatory programs that put the cost burden on them to recover more. So these AI are not just providing data, but providing real impact to the recycling value chain. And I guess I'll end here with saying that the demands on the recycling system are going up in terms of what is being asked to be recycled and how much of it. So the recovery rate for materials and the recycling rate for materials are just going up through policy and through commitments from consumer product goods, from demands from consumers themselves. And pretty much AI is going to be one of the critical technologies that is going to be needed to help with this burden on the recycling system. And I'll end there, but I've kept this at a fairly high level. And if there are more questions or details around any of this, my email is here, and please feel free to reach out to me. And I'll stop my presentation here.
Thank you, Apurva. Thank you so much for your great presentation. We're going to move now to Eric Law. Eric, one sec. All right, and Eric is the co-founder and CEO of Urban Machine, where he is using robotics to reclaim wood from construction and demolition waste, turning it into lumber for reuse. With a bachelor in mechanical engineering, Eric combines his passion for sustainability and technology to revolutionize material recovery in the construction industry. His work not only reduces waste, but also highlights the importance of innovation in achieving a circular economy. Thank you, Eric. Now it's with you.
Awesome. Thank you very much, Mariana. Hey, good afternoon, everyone. So at Urban Machine, we're building AI-powered machines to convert wood waste from construction and demolition into reclaimed lumber products. We believe it's about a $64 billion a year market that can be created from reclaimed lumber. Now, as we saw earlier from Apurva at Glacier Robotics, we're a little bit further behind than the plastics industry. They've obviously been recycling for much longer. And so we're building the technology, the workflows, and the processes to turn reclaimed lumber into finished products. The main problem we're solving is C&D facilities around the globe bury and burn about $136 billion worth of lumber every year. With lumber, when you grind it up and burn it, you are downcycling it into wood chips, and those wood chips are worth very little. And you're taking a very high value material. Lumber can typically sell for well over $400 a ton for reclaimed lumber, depending on the age and quality of it. When you take a look at the virgin supply chain, today logging operations happen in the forest. They cut down the trees, they go to a mill, the mill turns them into lumber products. Those products go into a building. The building gets renovated, it gets demolished, and then it ends up in a landfill or an incinerator. And so what we want to do is we want to close that loop with lumber, very similar to the many other products that are out there on the market today. And so what we're doing is we're taking the lumber from construction waste, from demolition, from those projects, we're turning it around, we're removing all the metal fasteners from it, so it can go back to those mills for reprocessing. This way it can be turned back into finished products and go back into buildings, creating a circular ecosystem. We call it reclaiming the past to build the future. Now, the great thing about lumber compared to concrete and steel, because we're actually keeping the dimensionality intact, is we can actually track and share the story. So we can actually put QR codes on our material so you can track the history of that material. The only place you can find old growth wood today is in buildings. You can't log it from the forest anymore. And so we're leveraging technology, not just AI, but the simple things like a QR code to track and trace that material and share that story going forward. Now, the technology that we've developed is we're leveraging AI. Our AI-powered machines are what does the heavy lifting. And what these machines are doing is they're removing all those metal fasteners from the lumber. And so we'll take a look at our machine. We've got one running here in Northern California. And what we do is we take waste lumber coming in from contractors, demolition contractors. You can see it's coming in racks to our facility here. These are coming from C&D facilities or directly from the job sites. And then we feed that material into our machines. And what the machine is doing is it's extracting the nails, screws, and staples to get the lumber metal free. Once it's metal free, then it can go back into a virgin lumber mill for processing. We cut the fasteners, we cook the fasteners, we heat them up to over 1,000 degrees. And what it does is it chars the wood, so it makes it much easier to extract. And then we pick them out. And throughout this process, we're using cameras, computer vision, and AI algorithms to identify those fasteners and the best technique for removing them and the orientation of our end effectors. And then we run it through a metal detector to make sure we got it all out. The good news is we have one requirement from our customers, and that is metal-free lumber. And then from that, we take this lumber and we can either post-process it with lumber partners where it gets milled or planed, or it can be turned into finished products like mass timber, furniture, engineered lumber products. There we go. So when we take a look at what's on the inside, so on the left-hand side here, the slide is how we receive material sometimes, tall side dump trucks that bring the material into our shop. We then remove all the metal fasteners from it. And then what's on the inside, you can find clear, high quality, clear grain material with very few or no knots. Again, this is a much higher quality product than what you're going to find at your local lumberyard. Recycling lumber is one of the few materials that gets recycled, where the older the material, the higher the quality it is. Whereas most products, the older they are, the lower grade they are. The two main things that we're recycling or reclaiming are dimensional lumber. We process everything from 2x4s up to 6x16 in cross section, 6 feet long to 40 plus feet in length. And then we also reprocess glulam beams as well. Same parameters, up to 6x16 in cross section, and we've processed 40 and 60 foot long glulams through our line. So there's a lot of opportunity to reclaim this material. Because wood reclamation has been done historically for architectural purposes, not only do we have to build the technology, but we're also developing products. So we're developing finished products to take to market that are made from recycled lumber. Like in the earlier presentation, they were talking about recycled plastics going into new products. Because we're a newer industry and recycling a newer material, we're building those out. And so two of those products are Dow laminated timber, which can be used for wall and ceiling panels, and then glulam blocks, which you can see we mill into various patterns, can be used to also build interior wall partitions and office partitions. So this is a great opportunity for designers, contractors to start to introduce large volumes of reclaimed lumber into their projects without having to take on any of the structural challenges of creating the whole building yet. We'll get there eventually. We're working with the grading agencies on reclaiming lumber and stamping it. You can regrade it today, but you just can't put a stamp on it. It comes with a certificate. So a little bit of friction that needs to be taken out of the supply chain there. The Dow laminated timber we really like because it's an all wood product. Uses less than 1% of the glue needed to construct CLT, resulting in little to no off-gassing. It's a beautiful product. It can really show the history of the material. And it's a great opportunity out there to demonstrate that you're using lumber in a sustainable way in your projects. And then the glulam blocks, it's 100% reclaimed. We're taking old structural glulams that were used to hold up buildings, coming from offices and schools and industrial buildings. And the great thing about this product is we're replacing steel stud and gypsum, which is a product that has very poor acoustics. It has a long build cycle because you got sand and finish. It creates a huge mess on the job site. With a prefab product that can be stacked into place, much shorter install time, much cleaner install, no drywall dust, and you get the beauty of wood and great acoustic properties. So it's really a high quality product that we've developed. A couple other things to note about reclaiming lumber. We're FSC certified. So we've got a stamp that says we're sourcing post-consumer lumber in our products. You get 100% diversion credit instead of 50 to 75%, depending on your municipality. And a cubic meter of wood salvage will save you about a ton of CO2. So for clients that are requiring CO2 reductions, using reclaimed lumber is a huge win, especially when you're comparing it to steel stud and gyp walls. It's a massive benefit for the customers. And so with that, there's a QR code. You can hit up our website, my contact information. If you've got any questions afterwards, feel free to ping me and ask questions, and we'd love to chat with you more about recycling lumber. Thank you.
Thank you so much, Eric, for your presentation. Now we're moving to Derek, Derek Davis. All right. And Derek is dedicated to helping organizations meet their zero waste goals as Zebo's customer success manager. With over 8 years of experience, Derek focuses on building trust, fostering client relationships, and offering personalized support to empower customers on their sustainability journeys. Passionate about nature and reducing environmental impact, Derek works to help others make tangible progress toward a cleaner and greener future. Thank you, Derek. It's with you.
Thanks, Marianne. Appreciate it. Hello, everyone. Thank you for having me here today. It's great to be here. Yeah, thanks for the intro. I'm Derek. I'm the customer success manager over at Zabel. So I work very closely with jurisdictions, universities, and other large organizations who use Zabel Zero to collect, aggregate, and analyze their waste data in ways they never could before. So my role is really focused on helping our clients set up Zabel according to their unique needs, helping them plan and strategize as they develop and optimize their waste programs, and really partnering with them to help them reach their goals and have a greater impact on their communities. Before I dive in, just quickly wanted to go over what I'll be covering today. So first, I'll talk a little bit about who we are and what we're trying to accomplish. I'll spend some time going over how Zabel Zero works, so you understand how organizations can use it to improve their waste operations. I'll walk you through some real-world examples of how our customers are using Zabel, and then I'll talk a little bit about kind of the broader topic of AI and waste. So a little bit about Zabel, just to give you a sense for who we are and what we're trying to accomplish. So we are a small software company based in Northern California, but we serve customers all over the US, from up in the Northeast, down to Florida, where I'm from, and all the way over to the West Coast. We are funded in part by the EPA, having won 4 EPA awards, and we have a patent for using artificial intelligence to automatically classify waste contaminants and bin fullness levels using a mobile device. So our mission is really to help large organizations, again, like jurisdictions, universities, and companies with large campuses to achieve their zero waste goals with real-time actionable insights using AI. So some of our customers, just to kind of set the stage, are universities like Stanford and Georgia State, jurisdictions across the country, such as the borough of Franklin Lakes in New Jersey, Fort Worth, Texas, Tampa, Florida, and others in California. And then other private organizations, such as the Golden State Warriors home stadium, the Chase Center in San Francisco. All of these organizations have waste operations that vary in size and complexity, but all of them have used Zabel to streamline their programs, gather better data, and reduce contamination. So how does it work? So it starts by equipping your field teams with the Zabel Zero mobile app available for iOS. So the mobile app allows your field team inspectors to view their route either on a list or a map, which includes a complete inventory of the receptacles that they will need to audit. This inventory can be imported in advance and managed in the web dashboard, making it easy to get set up and running. When the inspector is ready to inspect a bin, they simply snap a photo using their device camera, and our AI will automatically detect the bin's fullness and identify any contaminants based on the waste stream. They can also flag incidents such as overfull, oops, tag left, not set out, etc. So all of this can be done with little to no internet, because the app can perform offline and sync up when the connection is restored. So here's an example of an interior use case where the user is inspecting bins on the first floor of the administrative building on campus. They navigate to the Recycle tab, they select the appropriate bin, tap Scan, and right away you can see the Zabel AI detecting items in the bin, as well as the estimated fullness level. When the AI is confident in its classification, it will automatically tag the items that are contaminants, leaving out of the hands of the user. And then the inspector can flag any incidents that have occurred, which again will send an automatic notification to their team, and they're done. So based on the data we have from our customers, over 50% of these tags take between 6 and 14 seconds, with a median time of around 9 seconds. And in general, scanning a cluster of bins takes well under a minute to scan. Again, this is an example of an indoor use case, but Zabel is equally effective outdoors, whether it's a street of lidded recycle carts or an enclosure of dumpsters at a commercial building. Zabel's AI can detect contaminants with high accuracy, even in low light environments. And because our AI operates at the device level, you can do all of this without a stable internet connection. So it's not as if the AI is performing on the cloud. So on the data side of things, the data collection side of things, Zabel Zero is really designed to streamline the workflow, make each entry faster, and still be collecting better data than you would have otherwise. Our customers love the fact that they can ditch their clipboards and their clunky digital forms, and that they can inspect a bin in just seconds and still have a high quality image, automatic contamination and fullness data, and customizable fields that can send alerts to their team. Now, back in the office, your program managers and supervisors can view and analyze all this aggregated data that the field team has collected over time. The dashboard includes digestible visuals and metrics that will help your teams better understand where contamination is happening at the source, what kinds of contaminants you're seeing the most of, and all sorts of other insights that can help you reach certain goals like diversion or emissions reductions. You can drill down by address, street, neighborhood, or route to identify trends, spot problem areas, and curate your outreach and educational programs accordingly. The alerts that I mentioned earlier, which come from incidents reported in the field, can be viewed and managed in real time in the dashboard. So not only will stakeholders receive email notifications, but this list of alerts can be used for outreach, customer service, or internal task management for your teams. So this really helps with the follow-up actions you'll be taking after an audit has been completed. And this is really where the true power of Zabel comes into play. It's the ability to collect all of this granular data at the source level with such ease and speed, and then have it all organized and visualized for you in a way that saves hours and hours of data entry and analysis. So now that I've talked a little bit about how Zabel works, I'll switch gears and talk about how some of our customers are using it. I have 3 examples that I'd like to call out, and I'll start with one of the most recent, which really demonstrates how Zabel can help empower a small team to take on tough projects. Like many jurisdictions, the Borough of Franklin Lakes in New Jersey is a very small team tasked with monitoring participation and contamination in their waste streams. Franklin Lakes plans to do this annually, and the goal is to inspect a group of properties 4 times over the course of 2 months, returning every 2 weeks to revisit these properties and collect additional data. The longer-term goal is to develop a better enforcement program, and this first round of inspections that they did this year was designed to test this process out on a relatively small sample and establish some baseline expectations. Right off the bat, you can see that just 2 people were able to accomplish quite a lot out in the field. And although this program has not yet reached the maturity to start making really concrete programmatic changes, I think this particular example demonstrates how Zabel is a force multiplier for people both in the field and in the office. Equipped with Zabel, Lindsay and her team are more confident that they can scale this program to meet their goals. And just to give you a sense for some of the data they were able to collect, we were able to automatically track their participation rates, average fullness, specific contaminants from specific properties, and OOPS tag incidents based on the custom options that their team flagged out in the field. So this eliminated hours and hours of manual data entry and analysis, giving them that time back to focus on outreach and strategy rather than messing around with spreadsheets and calculators. The dashboard also makes it really easy to spot trends such as top contaminants, as seen in the word cloud at the top, and trends over time in terms of things like not set out rates, fail rates, and contamination, all of the above. So Franklin Lakes is just getting started with this program, and they do plan to scale it up from here, but they have already demonstrated that with the right tools, their very small team can accomplish way more than they originally thought. So we're really looking forward to them to help develop their operation and seeing the results of their hard work as the program grows. Switching gears a little bit, I'd like to talk about a very different use case. So we're really proud of our work with UCSF. We started working with them over 5 years ago, and they began using Zabel to track only a handful of buildings. But as they found success and began delivering results, they have since expanded their Zabel usage to cover over 80 buildings across 3 huge campuses and growing. They've done such an excellent job operationalizing their waste program and demonstrating results that they are really poised to expand their operation even further, and other organizations are using their operation as a template for their own programs. So UCSF was able to speed up their roadmap by identifying and tracking important and costly issues, reducing missed hauler pickups, and not just reducing contamination, but streamlining communication across their entire program. So Zabel really helps them bridge the communication gaps between the various teams automatically throughout their operation, which has resulted in some pretty significant cost and time savings. And so we spoke to UCSF just this last week about their future, and they have some really fantastic plans for 2025. And we're super excited that they're using Zabel to have such a huge impact on their organization. And lastly, I'd like to talk about the city of Oakland. Though their use case is it's pretty similar to the Franklin Lakes example I gave, but it is a larger scale operation that has had the benefit of a couple of years of prior contamination monitoring under their belt. So Oakland first switched over to Zabel in early 2024 after a couple of years of taking a more manual pen and paper approach to their inspections. They quickly realized that they needed a better solution for the program. And after adopting Zabel, they made really significant improvements to their operation. With double the productivity in the field, they were able to collect way more data than ever. And Zabel's web dashboard made the whole exercise more meaningful by providing better and more digestible insights. Rebecca, the team lead, understood that technology was going to play a really big role in the future of helping the city of Oakland operationalize this program so that they could reach their compliance, enforcement, and reporting requirements for California's new laws. But although the immediate focus was compliance with those laws, these insights will drive end-to-end data-driven outreach programs that will reduce contamination and produce cleaner materials for downstream processing overall. Their team is also looking to reallocate resources based on the priorities highlighted by their ongoing program data. For example, identifying contamination hotspots and material types allows them to target their outreach in very specific ways to help them save time and money. So after this initial round of route reviews using Zabel, the Oakland team is now seeking to start benchmarking against their past route review data, comparing performance over time, and optimizing their program to have a greater impact on the community. Cool. And kind of last but not least, I do want to step back a little bit and talk about more broadly about AI in waste. So just maybe a couple of thoughts on where we're at today and where we see things evolving in the future. So first of all, I think it's important to point out that here at Zabel, we are in the business of empowering people, not replacing them. So Zabel Zero is like an AI assistant. It takes what used to be tedious and cumbersome tasks and makes them faster, easier, and smarter, which allows the user to do more and have a greater impact. I think there's a lot of uncertainty and even some fear about what AI means for us all. And I do think that we have to be really thoughtful about how we implement it and leverage it. But what we see with our customers is that the Zabel AI simply enhances a person's experience and impact. And we look forward to continuing building AI like that. Another important topic is AI benchmarking. What does that mean exactly? Benchmarking, of course, is the practice of comparing business processes and metrics against industry best practices. When you have an established process, you definitely want to start thinking about benchmarking them. Kind of how I explained that the city of Oakland is establishing their own benchmarks that they can use for future comparisons. Likewise, we at Zabel are on our own benchmarking journey. Once we start benchmarking the performance of the AI, its accuracy, and its impact for specific use cases, we can then start to really make progress towards achieving our zero waste goals. And the more AI software companies contribute to industry-wide AI benchmarking, the better the results will be for end users and us all. I think in order to have that open and transparent dialogue about this, we need to regularly share our AI performance metrics and start to establish some really key industry-wide benchmarking. And the more we do this, the more we pave the way for AI and waste. In terms of compliance, I think as many of you probably know, it's becoming more and more common for states to pass legislation such as SB 1383 in California, which is aimed at reducing organic material from entering landfills, or SB 54, a new and groundbreaking extended producer responsibility, or EPR law, that has also taken effect in Colorado, Oregon, Maryland, and Maine. This means that municipalities, manufacturers, and generators are going to experience more scrutiny into the role they play in the recycling value chain. And we're going to see more municipalities enter the monitoring and enforcement phase. So compliance is a big topic for many, and we think that AI will play a significant role here to ensure that the organizations that are impacted are able to adapt to these new expectations. And lastly, another key topic for us at Zabel is targeted outreach. As organizations embrace an AI-assisted, data-driven approach to waste management, they're going to need better tools that give them more granular insights and more importantly, the ability to react to those insights in a scalable way. So one size does not fit all when it comes to education and outreach. And it's really important for organizations to experiment with multiple methods to figure out what has the most impact on their customers, their community, and help save them time and money. So it's one of our goals over at Zabel to help find AI-powered solutions that help them achieve this. So those are just some of my more broad thoughts on AI. And that pretty much wraps it up for me. Thanks for having me here. This was fun. I appreciate the opportunity to share what we do, highlight some of our customers' successes, and talk about AI. So if you think that Zabel could help your organization reach your waste goals, feel free to reach out to our team. We'd love to talk to you. And that's it for me. Thank you.
Thank you, Derek. Thank you so much for your great presentation. And now we're going to move to our Q&A. So please, Apurva and Eric, please join with your cameras on as well. All right. So first questions here will go in the order of presentation. So to Apurva, the questions on the chat were, does non-robotic systems work similarly?
Non-robotic sorting systems, there's different types. There are, sort of some of the more commonly found non-robotic sorting systems are screens and eddy current separators and optical sorters. So there's sort of three that most recycling facilities have. Screens and eddy current systems don't have any sort of detection capabilities. They're just set to a certain set of parameters and they do what they do. So if composition changes or the types of material coming in or changes, their performance will suffer. Optical sorters do have detection systems. So optical sorters use infrared technology to detect what's coming in. Infrared technology is very good at making sort of material distinctions between different types of plastics and different types of metals. They're not as good in detecting the types of packaging. So they don't know whether something's a bottle or a container or something is has a plastic wrapper around it that's kind of confusing the infrared detector into thinking it's something else. So it has some limitations there. So it depends on what sort of sorting technologies you're talking about. Yeah, some do and some don't have any inputs into them.
Thank you. And just to let Eric and Derek and also Apurva know, whatever question I make, if it's even if it's specific to someone, you can all chime in and say and make a comment, whatever you want to add to it. So moving to the next question to Apurva, I believe. I believe your robotic accuracy rate was 90 to 95%. Is this based on a single run of the materials or multiple runs of the same material?
Yeah, good question. So When you talk about robotic sorting, there's two accuracies that you need to keep in mind. One is the accuracy of the AI system itself in terms of identification. So if an AI system makes a prediction on whether an object is a certain type of an object, how well did it do that? So that's an accuracy number. Our AI is across the 60 or so commonly identified material over 90% and oftentimes over 95%. And then there's an accuracy of the robot itself. So this is sort of a mechanical accuracy. If I went for an object, did I pick that object properly or not? And that is a pick success or a pick efficacy number. And that number, we average number is about 90% pick success. So 9 out of 10 times that a robot goes for an object, it accurately grabs it. We guarantee a level of 80% or higher. I think we're the only company that's able to do that because of some of the developments we've done on the robotic side. So the floor really for us is 80%. 8 out of 10 times a robot goes for an object, it picks it. Typically, it's about 9 out of 10 times.
Perfect, thank you. And another question for you was, what about maintenance of the systems and robots? Does your company provide that periodically, or do MRFs need to have the technicians?
Yeah, that's a really good question. So one of the things that we learned super early on is, recycling facilities, MRFs, reclaimers, reprocessors, mills, they don't have the type of people needed to operate a robotic system or an AI system. So we built a infrastructure, both sort of technical infrastructure as well as people that run these robots remotely. So we've got robots and outfitted with sensors and cameras, so we know exactly what's going on at any given time. Our AI model is constantly checking itself, monitoring its success and raising flags where we have lack of data or some of the results are not clear to the AI. So the confidence score is low, and we're always checking those. And so we've built a solution that's sort of turnkey and completely hands-off for the recycling facility. So we'll install it, we'll monitor it, we'll do the troubleshooting. There is some small things that the recycling facility has to do. So there's some housekeeping things. So on a daily or a weekly basis, there's kind of consumables that they need to change out, and we send warnings or notifications on when those things need to happen. The recycling facility, they need to make sure that there's power, internet connection, and pressurized air supply, and that's sort of the level of involvement that the recycling facility needs to have. The rest of it we take care of.
Thank you. And now moving for questions for Eric. Are there other CND materials in addition to wood that your AI solution targets or will target in the future?
Yeah, so we're focused on dimensional lumber and the glulam now. And then down the road, we're going to expand into sheet goods, things like plywood, oriented strand board, and then any materials where there's fasteners. So architectural wall claddings and sidings will go after, potentially drywall as well. Is really what our core technology is suited for. And it's just changing the form factor and the process line to handle those different shapes and sizes of materials.
And I believe the second question is a little bit about CND as well. This sounds excellent for CND landfills that are generally short on space. Do they deliver the lumber, or does your team generally pick it up?
Yeah, so for the current partners that we're working with, we've had both. So typically they sort it and load it into racks, and then we have trucks that bring it from their facilities to ours. And again, it depends on the size of the facility. Some of the smaller ones who don't have space for the system, they'll bring it to a central location where we're operating. And then we're talking with larger ones who have the real estate to put our systems on site so they can feed it from the tipping floor directly into our machines.
Perfect, thank you. And also a question for you, Eric. Where is this technology currently available?
Yeah, so currently we have our first system running in Northern California, so about an hour north of the San Francisco Bay Area. And we're looking to expand next year. We're exploring opportunities in Colorado and Oregon and Washington. British Columbia. We got a couple up in Canada that we're looking at, one in Texas we're looking at as well. So we're open to talking with folks that have access to the waste and want to recycle it, about setting up systems and partnerships in their markets. We're really targeting major metropolitan areas where they have lots of material available that needs to be cleaned up and turned back into the local building market.
Perfect, thank you. And now moving to Derek. Question to you is, how does the content feature work for the items at the bottom of I believe it was a tall bin, or is it just meant for a general view from the top?
Yeah, that's a great question. So the ultimate goal of using Zabel is to collect sample data from the surface. So there are times where our users rummage a bit and try to pull things out and set them to try to identify contamination that might be just under. But a lot of times, most of the time, the ultimate goal is to grab that quick snapshot of the surface. And then the idea being that if you collect enough of this sample data in enough volume, it becomes representative of what is in the rest, right? And so it's meant to be a small sample that in great volume gets you to the same data that you're looking for without having to commit to a full sorting process, which Zabel can also support. So most of our use cases are really about collecting that quick and easy sample data at great scale and great volume to get to the data we're looking for.
Got it, thank you. And second question was, is Zabel being used to do general waste audits, and do independent waste audit firms use this, or is it generally municipalities?
Yeah, the short answer is yes. So we do have quite a few use cases across our different customers. I'll highlight one. So we do work with a waste auditing company firm that their customer, the end customer, has asked basically two things of them. Please monitor our contamination over time and tell us what we're doing wrong and how we can fix it. And periodically perform waste audits, like a true waste study of bagged trash, to really dig in and get specific numbers about specific samples of waste. And so the short answer is yes. So not only is Zabel used effectively for ongoing contamination monitoring across large campuses over time, but we have seen it used to great effect in sample waste characterization studies and audits, whether that's scanning the top of bags that we've opened and scanning 200 bags that we've laid out in the room, or really digging in and spreading out some trash and using Zabel to kind of to identify the contamination and track the data.
Yeah, and there was a comment on that question that was, I'm thinking of composition audits which MRFs generally don't want to do because it takes too much time and resources.
Yeah, I think on the topic of like true waste characterization studies where we're actually looking at all of the waste spread out on a table, for example, a lot of our customers have done this where, we're gonna empty the bag out and look at every piece of trash that's in here. The Zabel AI, when it was originally designed, was designed for a top-down view of a bin. And so we've been working to expand and train our model on additional use cases like what I described. And so I think there's probably a future for a use case like that. For now, what we've seen the most success with is like sample studies, like kind of what I described. But yeah, that's good feedback. Thank you.
Thank you. And other question was, what does Zabel mean and why the name Zabel?
Yeah, it's a good question. It's actually when Zabel was originally founded, the inspiration is actually a people group called the Zableen in Egypt. And basically, this people group was well known for being kind of unofficial garbage sorters. And so they were kind of creating their own little circular economy by, sorting garbage and repurposing it, composting it, selling it. And so the idea of Zabel being this tool that you can use to, basically do the same thing officially, I think that's where the inspiration came from. Yeah.
That's cool. And now a question for all of you. How can AI be used to increase collaboration to improve recycling? And then I'll start with Apurva and then go along with Eric and Derek. And
Sorry, Marion, can you repeat the question there?
how can AI be used to increase collaboration to improve recycling?
Yeah, that's a good question. So, I think in my presentation I mentioned, there's various stakeholders in this recycling process, and you've got material moving from one stakeholder to the next as it becomes recycled, right? And so definitely sharing information across this value chain will bring the industry closer together. And so I'll give you an example. So, I didn't go through this case study in my presentation, but I know I'll attach it to the version that I send out that you can download. But we've worked with trade associations to improve recovery rate of specific packaging. So there's a trade association called Can Manufacturers Institute. So they represent all the manufacturers of aluminum cans that are used for beverages. And this is a huge industry, right? As billions and billions of cans that are being produced. And aluminum is one of those commodities that can be recycled over and over again. And a big priority for aluminum manufacturers is to use reclaimed aluminum back into making a new can because it's a lot more cost effective for them. I think aluminum is I think it takes about 1/10 of the energy and cost to make aluminum can out of recycled aluminum versus mining new aluminum. So there's a huge economic benefit for them. But for them, they were trying to figure out how do they work with recycling companies so that they can improve recovery of aluminum cans. One of the things that we helped them do was create sort of a financing model for financing our technology into material recovery facilities. So basically, they created a kind of a program where they would provide the AI and robotics to a material recovery facility, and the robotics and the AI would be programmed to recover as much aluminum as possible from going into landfill. So it was going into what's called last chance lines or residue lines and picking aluminum cans. And out of the money that the material recovery facility got from those recovered cans, they were paying back the Can Manufacturers Institute. So it's kind of the technology sort of paying for itself. And basically the initiative was triggered by the trade associations of the packaging manufacturers. So that was a kind of a very cool way of industry associations and recyclers working together on a common cause, right? So AI and robotics and these sorts of technologies provide an extra level of capability to sort of bring together, starting with data and what's going in and out, but also then, sort of automation technologies to sort of tie together the goals of these different organizations.
Right. Eric?
Yeah, I think the big benefit of AI is it's going to allow us to move faster. If you take a look at these virgin supply chains, they have evolved from, small facilities over hundreds of years ago before computers even existed to massive, highly scaled operations, right? If you look at like an aluminum pit mine in the case of the aluminum example, or oil and gas, or lumber, right? Lumber, I mean, they harvest massive amounts, hundreds of millions of board feet through a single facility. And so how do we play catch up to reach those scales is the big challenge for all recycled products. And I think that's where AI is going to come in place and allow us to learn quickly, adapt quickly, and also create small micro manufacturing facilities, because all of our raw material is distributed, right? We took a forest and we cut it down and we spread that lumber all over the world, or all over North America for those of us here in the US. And now we've got to recover all that material, clean it up, and get it back in the supply chain. And so that's where I think AI's real benefits are going to come into play, is leveraging that distributed raw material feedstock and getting it back into finished products.
Thank you. And Derek?
Yeah, in terms of collaboration, I think it really comes down to organizations that find success sharing their success. I think two of the case studies that I showed to you are also case studies we show to others, which are, the UCSF, specifically kind of in the university track, and then Oakland in the jurisdiction track. And, the requirements on either end are different, right? So you have laws like SB 1383 encouraging jurisdictions to take a technology-focused approach to their contamination monitoring. And on the university side, you have, for the past decade or so, universities have taken all these zero waste goals in good faith, trying to make the world better. And so both of those present challenges, and whether it's countless jurisdictions across the country or all the universities that we know, they're all trying to do it in different ways. Some are failing, some are succeeding, and they're all working towards that same goal. But the organizations that kind of cut through and find really good success with operationalizing these things, like UCSF, like Oakland, if they share that success, which they've all been willing to do, it goes a long way. And so, for example, the Borough of Franklin Lakes, closely emulated what Oakland do. And even with only a team of 2 people, because they had the tools that Oakland used, they were actually able to accomplish something. And likewise, we're seeing the same thing on the university side, that UCSF's willingness to share that case study, to share their successes and teach others, has gone a long way to helping other organizations follow suit.
Thank you. One more question that I'll make to you, and then I'll move to the new questions in the chat. How quickly can the AI train on new materials? And that would be, I believe, to start with the Aperba, and then you all can comment on that as well.
Sure, I can talk about our AI. So, one of the things that we encountered initially is sort of the variability and the sort of the unstructured nature of detecting objects in the recycling stream. So, 2 objects don't look anything alike when they show up in a recycling facility. Also, from day to day, week to week, facility to facility, you will have new objects coming in. And so we've had to make the model extremely adaptable to those types of situations. And so we've built our training infrastructure, our AI training infrastructure, so that we can recognize, identify, train, and fine-tune the AI within a week or 2. So if a recycling facility came to us and said, hey, we want to start picking this new object this week, we could then kick off a training where we would initially start with real data, but then we could generate some synthetic data to augment that and be able to recognize that object with greater than sort of 90% accuracy within about 2 weeks. So the AI is sort of built for that sort of adaptability.
Thank you. And Eric?
Yeah, so ours has been growing as we process different types of material and different ages of materials. We've seen everything from round nails to square nails to handcrafted pegs. It just depends on the age of the material. And the more material we process, the smarter it gets. And then the other piece of it is the material itself. We're working on our AI to look at how can it predict the species of the wood, the age of the wood, the quality of the wood, the volume of the wood. One of the big things that our customers are interested in is predicting inventory, right? So after they've been running enough material through our system, what will they expect to generate so they can pre-sell it before they've even processed material? Because we want to keep everybody out of the inventory business. And so those are kind of major points that we're working on developing with our AI to help out our customers. Is really there's the internal, the prediction and solving the problem, removing the fasteners, and then there's the customer-facing AI, which is the inventory side of it.
Perfect. Derek?
Yeah, I won't add too much more. I think, it really comes down to the volume of data. I think as a smaller startup, and I think if you can imagine the difference between waste on a conveyor belt under your camera versus scanning the top of a bin, there's just a difference in the amount of volume of data. And so I think, and then you have a customer that's saying, well, I want this to identify food scraps. Well, what does that mean? Food scraps could be jelly on a bread or a banana, or an unlimited number of things that the AI has to learn how to see. And so it is tricky. I think probably our training cycle is a little bit longer than what Aperba referenced, just because of the sheer, the lack of constant data coming through. But we do work really hard to continuously train. And we are, we currently train 10 categories of items. So we can identify quite a lot of items within those 11 categories. And then, we're just, working really hard to add more and more to it.
Thank you. And a question from the chat. Not sure if you'll be able to answer that one because it's about EPR bills. So is AI being integrated into any EPR bills? Does any of you know about that?
Not that I'm aware of.
Yeah, so it's not, there's no mandate for using AI in EPR bills, but there are mandates for auditing waste. There are mandates for increasing recovery rates, and those inevitably the way to do that is through an AI system, right? I think like manually trying to audit things at a level where it gives you a representative, kind of a representative view into the waste stream or the recycling stream. Manually doing that is very, very difficult. So I think AI is going to need to be a necessary component of that. Increasing recovery rates, and different places have different sort of rates at which they need to increase their recovery rates. Keeping up those rates is not going to be simple just using existing equipment. They're going to have to audit it, augment it with AI and robotics and other technologies. So it's not inherently in the bills, but I think it's going to be a tool that's going to be necessary to implement these bills.
Any other comments on that?
I was just going to say, typically in legislation, we don't like to see them specifying specific tools because that means only one vendor or one company can do it. It's better to say, hey, we want you guys to recycle things or want you to be responsible for your products, stuff like that. And then all the startups and the companies around it can go solve the problem with hardware, software, AI, no AI. It's up to the tech guys on how to solve it.
Yeah, perfect. And another question, I think this one is for Everest Labs. So, Apurva, is there going to be case study details for the trial of Everest Labs robotics by LRS Waste Management of Rosemont, Illinois, too?
Yeah,
You've mentioned a bit, yeah.
Sure. So yeah, that's a very successful case study for us. I'll add it into the deck that you can download. But the short answer there is we have a robot that's funded into and installed into the LRS, the exchange, which is the MRF in Chicago. That one robot is picking something to the order of 8,000 cans per week, which is kind of like getting close to like 2 million cans a year. So we've kind of computed all the economic and sort of environmental benefits of that, of just using one robot. I think that's a huge success story for sort of the aluminum recovery industry. So yeah, I'll include it, but that's a very, very nice example of the use of robotics in these systems.
Thank you. And question here in the chat. I think I'll start with, will AI be able to keep up with the super rate of changing material types? I think you guys mentioned a little bit on the learning process, but if you can comment on that a bit more.
So I'm not quite clear on the
question. The question is, will
Can
AI be able to keep up with the super rate of changing material types?
Yeah, so material types are changing, but I guess it depends on what you mean, right? So if you look at it from a material standpoint, like the material composition standpoint, it's not really changing that much, right? So the different types of plastics, metals, paper that are being used, that's sort of the same raw materials that's going to be used. Packaging types are changing constantly, right? But it's changing within sort of parameters that we know about, right? Somebody might make a bigger bottle, smaller bottle. Somebody might use HDPE instead of PET to do something, vice versa. Somebody might use a packaging wrapper that's a different composition than the actual packaging itself. So those things are constantly happening, and those changes, especially ones that are problematic. So, for example, we have facilities that we were using AI to identify sort of HDPE natural, which is a type of plastic that's used to make milk jugs, right? And we were using HDP, and then over time, a producer started using PET to make those same milk jugs. And so, it doesn't happen all that often, but this milk jug started becoming more and more prevalent in this particular area. And, within a few weeks of this happening, the AI kind of flagged some issues with the detection, and we were able to reclassify that into a PET, and then sort of pick that out as a contaminant. So I think that materials are changing, but it's not changing to a degree where it's going to make these technologies obsolete or not be able to keep up.
Yeah, the comment here from Rhonda, which is the person that asked that, said that thinking of plastic mixed with other materials that make it virtually unrecyclable. That was her thought, I think.
Yeah, I mean, so identifying it, sorting it, separating it is different from sort of reprocessing that plastic back into virgin material, right? Like so, but I think like packaging companies and brands also have a concerted effort to try to make things out of sort of standard materials that can be recycled as well.
Yeah, I think that's a great question, because there's a lot of so-called sustainability companies that are taking plastic and mixing it with other products and calling it sustainable and made from recycled, but that's it, it's end of life. My favorite one is Trex decking, right? It's garbage at the end of its life. It's wood and plastic, right? Two materials that should never have been merged together. And so, will the AI be able to pick them out? Absolutely. Can you do anything with it? Probably not. So that's kind of, everybody's got to be real careful when they pick products, what they make them. If it's a virgin, if it's a pure plastic, pure wood, pure steel, pure aluminum product, those are much easier to recycle.
Yeah. And moving on, a question to you, Eric, then, as you're talking about Urban Machine, what inspired you then to focus on reclaiming wood from construction and demolition waste, and how does Urban Machines technology addresses those challenges in the process compared, for example, to the traditional method?
Yeah, so the idea for this came, I used to, or before Urban Machine, I worked for a large contractor here based in the San Francisco Bay Area, and we had a large mass timber division that was creating these beautiful large wood structures out of mass timber products. And we started looking at our waste streams coming off of our other projects, and we had massive amounts of wood. And it's like, okay, how do we connect these two, right? How do we take this waste from concrete formwork, temp structures, just cutoffs from stick frame structures, and move it into mass timber buildings? And the feedback was, well, unfortunately, there's no way to economically get the fasteners out. It was just too cost expensive and too laborious for humans to go pull nails, screws, and staples. And so that was the impetus of, hey, if we're going to recycle this material, we got to get it metal free, so then you can plane it and post process it. And then that was what led to the start of Urban Machine. Over the last 20 years, I've been in construction and tech. This is probably my third or fourth startup that I've had. The most successful one previously was a SaaS company that I sold back in 2015. So it's a good challenge that's got construction, technology, and sustainability woven into one.
Perfect, thank you. And last question here for Derek. If anyone don't have any more questions to add to the chat, this would be the last one. So Derek, how do you measure the success of your clients' sustainability initiatives? And what role does AI play in tracking and improving these metrics?
Yeah, we have different customers with different goals. Some of those goals are enforced by laws. Some are, enforced by business leaders. And it could be, I need you to reduce contamination, or I need to increase diversion, or maybe someone's interested in reducing emissions. So we have different ways to track those. I think our bread and butter is contamination monitoring, right? And so I think we have the most impact when our customers are very focused on reducing contamination through education, through smart data collection and analysis, followed by like really great outreach and education. So at the end of the day, it's simple math. We collect the data, we do the math, we can tell you exactly what percentage your streams are contaminated and from where. And then we can, consult with you and work with you to figure out the best way to go out and, and do your outreach and educate the end user, the customer, the generator on how to do better. And so I think, contamination is a big one, but we also, like I said, track diversion, participation rate, other metrics. And, it's as long as we have the data, we can do the math. And so whatever the customer's end goal is what we can help them track and manage. Yeah.
Perfect. Thank you. Thank you so much, Derek, Apurva, and Eric for the presentations today. Thank you all for attending today's webinar and for your interest in exploring how AI can transform the waste management. And if you haven't already, be sure to check out part 1 as well of the series. It will be available soon on the NERC website, nerc.org, as well as today's session. We hope that you've gained valuable insights and ideas from all of these presenters. And thank you again and have a great day, you all.
Thank you, Mariana.
Thank you, everyone.
Thank you, everyone.
Thank you.